Alright, Joe, with this video we're going to be talking about the system, or not the system, the method of solving equations using graphs. This one is probably the easiest and most visually sensible. Definitely something that makes sense when you look at it on a graph. So something I want to talk about first is what is a line. So a line, yeah, it's something that you draw on a graph or whatever, but what it really represents is a bunch of different dots, and those dots represents potential solutions. So if we have an x and a y value that have not been defined, and we say x plus y equals 2, what we can do is find all of those points where x plus y together equal 2. For example, when x is 1 and y is 1, x plus y equals 2. So that works, right? What about when x is 2 and y is 0? That works. Or opposite, x is 0, y is 2, right? What if we get into the nitty-gritty? What if we go 0.5 for x and 1.5 for y? Yeah, that works, right? Same thing. 1.5 for x, 0.5 for y. And we could get smaller and smaller and smaller and more specific and more specific. And what we would end up with, as we kept going and going and going and going into the negatives even, because what's negative 1 plus 3? That's 2, so that works. Well, what about 3 plus negative 1? That's 2, so that works, right? So a line is really just a collection of data, more specifically a collection of solutions for any particular equation. So when we have an intersection of two lines, not only does that mean that this is a solution to one of the equations, but this point here, the intersection, is the solution to both sets or both equations, right? Because that spot on the graph is the spot, the only spot in this sense, where the two lines share a solution. So we're going to be using that information to solve systems of equations like this. To solve systems of equations like this, I think it's kind of hard to graph equations when they look like that. So what we're going to do is we're going to change it into y equals mx plus b, which is slope-intercept form. Once again, that's slope-intercept form. I wrote it up there for you. So what we're going to do to get it into that form is subtract 4x from both sides. So we have negative 4x. And then we can divide everything by negative 2. So we end up with y equals negative 8 plus 2x for that first equation. And we'll go ahead and graph that in a second. But then for the second equation, we'll do the same thing. Move the x over to the other side. And then we'll multiply by 2. Because that's the same thing as dividing by 1/2. And then we get y equals 14 minus 20x. So this one might not be very easy to graph on this here graph that I have. But what we can do is go ahead and go to Desmos and graph these on there. So we can plug in our equations. Y equals negative 8 plus 2x. I got it right here. If you can't see it, I rewrite it. And then our second equation, y equals 14 minus 20x. And so once we zoom in on that one spot where we see the intersection, we'll look at what this graph says, and we see that this is -2, 2, so this is probably 0, right? And this is -6, so we're at -6. And so therefore, our answer to this system of equations is going to be 0, -6. And if we didn't use Desmos, we just graphed it, what we would do is use our information, knowing that we had y equals -20x plus 14, right? And y equals 2x minus 8. Here's our y-intercept, -8. Our other y-intercept is going to be way up there. And 20x is that huge slope, and then 2x here is this slope here of 2. So that's graphing and solving systems of equations with graphing. Like I said, this makes the most sense to me. You can visually see where the two graphs intersect and where they share an answer. And it's pretty easy to just get these equations into familiar forms. All you have to do is just get it into a form that you know how to graph. And once you get into a form like that, you do so and you make note of wherever that shared solution is. So we'll see you in the next couple videos for matrix operations. Thanks for sticking around.